Students, hello. I'm G. Prasad, and you're attending a session on triangles chapter, right? So triangles was there for you in grade 9 as well, correct? And now you're studying it again in grade 10. So what's the difference between the triangles chapter that you studied in grade 9 and the one which you're studying now? You studied, huh? Yeah. Mostly there was congruency in that, right? Congruent triangles, Pythagoras theorem. Pythagoras theorem will be coming again today, okay? But instead of congruency, we have something called as. But in this session, you will be actually seeing few questions which are not difficult but a bit tricky. Okay, the way you apply the concepts, all right, that is kind of out of the way of it. Right? So we'll discuss various problems concerning the chapter of similar triangles. All right. So let's take the first one. You can see the screen. Yeah. So what does it say? There's a big circle, okay, and within that we have smaller circles, and you need to find area of the shaded region, the orange region. Okay. They have given EF is equal to 6 units and FG is equal to 3 units. Okay. So based on this, you have to come up with the thing. All right. Yes. So how do you think you can? Yeah, coming up in your mind. Think. As you keep thinking, okay, this particular problem, I'll give you a hint. Okay, a small hint, but that will be through another problem. Okay, and that problem is this. Okay. This is a, you could say, simpler version of the earlier one. Here you can see a square. The side of the square is x units, and there are lines drawn. Okay, let's name it. Say AB is 12 units. Okay. BC is 3 units, and CD is 9 units. All right, AB, BC, CD. It's like a zigzag kind of thing. But angle ABC is 90. Similarly, angle B. This is like a precursor to that circles question. Don't worry, that seems like a question from circles, but that involves similar triangle, the one which you saw earlier. So we'll be solving that after this. Okay. Just take a minute to solve this. Remember, this is not straight. Okay, A, B, C, D is not straight. Take care. And if you try to join DB, okay, and AC, again, there's no direct relationship between them. Okay, so take care of that. How will you solve? You can have the kind of construction, it should be within the simple domain. You have to solve it very quickly. Okay, so make some construction so that you can solve this question with an ease. Okay. Yeah, I'll give you another 10 seconds. Will that be sufficient? No. Okay. Let's make one small construction. See if you are able to get the construction that I am making. Okay. We are going to construct a rectangle. What is a rectangle? Rectangle is a side, is an object where the opposite sides are equal. Okay. This is equal to this, this is equal to this. Correct? Why? Make this and we join. This is a rectangle. Let's name this some So we just now constructed a rectangle CDEB. CDEB. This is a rectangle. This by construction. Okay. Now, what is the advantage of this? Can you tell me? Very good. Which sides will be equal? CD will be equal to BE. Correct. Very good. Okay. CD will be equal to BE. Okay. Opposite sides of the rectangle. Okay. Similarly, CB will also be equal to DE. Again the same. Okay. Same property. Opposite sides of a rectangle are equal in length. Okay. So can I write this as 9? So BE becomes 9 because CD is 9, is equal to 9. Okay. And this is equal to 3. Now can you tell me what is the advantage of this? Yes. So if you draw, if you draw the diagonal like this, okay. So AD is the diagonal of the square. AD. What is that? AD is the hypotenuse of which triangle? Triangle AED. Can you see? AD is the hypotenuse of the triangle AED. Because this was a rectangle, this is 90 degree. Correct? So angle AED is 90 degrees. So what can we say using Pythagoras theorem? We can say that AD square, okay, AD square is equal to root of AE square plus ED square plus ED square. Is this clear? Just go through the diagram again. Okay, triangle A completed the figure. Okay, and this is D, and this is all right. So AD square is equal to AE square plus DE square. Now what is AE? AE is AB plus BE. Okay, AB was 12, BE was 9. Okay, so total becomes 21. Okay, so AE is equal to 21. Similarly, what is DE? DE we are taught as 3. So now we have a right angle triangle with sides 3 and 21 units. Okay, so can you calculate AD using this? So this is equal to root of 21. How much is that? Yes. Root of 21 square plus 3 square is equal to root of 441 plus 9, which is equal to root of. Okay. This is a very odd looking answer, root of 450. What can we do? We can write root of 450 as equal to root of, yes, 2 into, correct, 225. Why are we doing this, guys? Ah, 225 is very good, 15 square. Okay, so we can write this as root of 2 into 15 square. Okay, so this is how much? 15. Okay, so the diagonal AD of the square is 15 root 2. Okay, now can we find the side of the square? If diagonal of a square is 15 root 2, okay, diagonal of the square is 15 root 2, then what will be the side of the square? If you guys know trigonometry, you can directly use trigonometry because this angle is 45 degrees. Okay, if not also you can use theorem. This is x, this is also x, this is 90 degrees. Okay, so root of x square plus x square is equal to 15 root 2. Okay, so how much is this? Root of 2x square is equal to 15 root 2. Okay, that is root 2x is equal to 15. So root 2 gets cancelled, x is equal to. Okay, very good. So x is equal to 15. That's your answer. Right? Now listen. What we did, we constructed a particular rectangle, and because of that, we could shift that will be applying in the circles question. Okay, in this particular question, we will be applying the same concept. Okay, let's try to make rectangles. It's a very convenient tool whenever you are given some lengths which are not directly telling us what the answer is. Okay, so let's see how to do this. Okay, let's first name it. Okay, let's call this O1. Okay, this is the center of the bigger circle, this circle. Okay, let this be O. What is O? O is the center of the biggest circle, the largest circle. Okay, O1 is for this circle, center of this circle. O2 is what? O2 is center of the medium circle, the third circle, this one. Okay, and O3 is circle. Okay, let me use some other color because it may not be visible to you. This is O3. Is it visible? Is it clear? I have just named it. Okay. Next, please join O1 and E. O1 and E. Alright. Similarly, join O2 and F. Okay. Now, can you guys tell me what will be this angle and this angle? It's not from Triangles chapter, correct? It's a tricky question. It combines. Yes. Very good. So it is 90 degrees. Why? EF is E. This is F. EF is tangent to both the circles, and O1E and O2F are radii. So they will touch each other at right angles at the point of contact. Okay, very good. Very, very good. Now comes the rectangle part, the one which we did in the earlier question, right? That is exactly what we are going to do here. Okay. So we are going to construct a rectangle because we already have 90 degrees here. So what I'm going to do is just observe carefully. Just observe carefully. This will go on like this. Okay. Let's call this point EFGH. This is the point H. Okay, what have we done? Get this and this are that. But because of that, what do we get? EFO2H. EFO2H O2H is a rectangle. Okay, why? Because this is 90, this is 90, okay, and we constructed EF parallel to O2H. Alright, so they are parallel, therefore this also becomes 90 and 90. Okay, so it becomes a rectangle. Till here, is it clear? Okay, it's a construction, guys. We are not because of which EFO2H becomes a rectangle. Okay. Yes. Now have a look at this line O1H. Line O1H. Okay. Can you tell me what will be the length of O1H? Before coming to that, let's say that this particular circle, this one is having radius R1. This one is having a radius R1. Alright. Similarly, let's say this is having radius R2. Okay. And the third one is having radius R3. Okay, so we have R1 as the radii of the three circles which are inside. Okay, in decreasing order. R1 is greater than R2, R2 is greater than R3. Okay, it's just for some sign convention we want, right? Some normal labeling we want. For that we are doing. Okay, yes. Now can you tell me O1H in terms of R1 and R2? Can you tell me O1H, which is this length, okay, in terms of R1 and R2? Just take a couple of seconds, not couple of seconds, couple of minutes, and tell me. You have to use the rectangle. Use the rectangle. The way we used in the earlier question, similar to that. Okay, opposite sides of a rectangle are equal in length. So O2F is the radius of the smaller circle, correct? So this is R2. Can I say O2F is R2? Yes, O2F. R2F? No. Therefore, HE, because this is opposite of O2F and it's a rectangle, HE will be equal to O2F, which will be equal to R. Focus carefully. HE will be equal to O2F, which and O1E. Okay, this one. I'll use another color. Which color should I use? Green. Okay. O1E. Can you see? Is radius of that circle, which is R1. Okay, so O1E is equal to R1. Alright. Now what is O1H? O1H, this part, the smaller part, is essentially O1E minus what? H, correct. Okay. O1H is O1E minus E is what? R1. HE is R2. So we can write O1H, I'll change the color. O1H is equal to O1E minus HE. O1E was R1 and HE was. Is this clear? Yes. Okay. So O1H is equal to R1 minus R. Now, why did we do this? What was the need for doing this? Think. Correct. So one side now we have got as R1 minus R2, and what will be O1, O2? The hypotenuse. This point from O1 to this point, let's call this point some Z. So O1Z is R1. It's again radius of the circle, O1Z. Okay, and O2Z is R2. Right? So this part is R1 and this part is R2. So your hypotenuse of that triangle, that is O1, O2, O1, O2 becomes R1 plus R2. O1Z is equal to what? O1Z plus O2Z. Okay, which is nothing but R1 plus R2. Okay, yeah, take care. Ekdam carefully you have to do this. Very careful. And this red line, can you see? O2H, that is the opposite side of this rectangle. Okay, this side is 6. Opposite to that you have O2H. Therefore, O2H is also 6 units. Is this clear? Yeah, take some time, take some time. This one is R1 plus R2. Okay. This one is R1 minus R2. This is opposite to this, so this is 6 units. Alright. Similarly, okay, I won't go in detail, but similarly, if I draw a triangle like this, okay, a small triangle like this, same kind of construction for the other two circles. I'm drawing a rectangle here, okay, and there is a small triangle here, okay. You would get similar relation. That figure I'm going to draw again. Okay, so let's draw only that part. So we have one triangle, right angle triangle, like this. Okay, and the other triangle, which is smaller one. Okay, it's your homework to do it for the smaller one. Okay, in the same manner you have to do. Okay, bring all the sides in the ratio or in terms of R1, R2 and R3. Okay, we had got this one as how much? R1 minus R2. Okay, this side was how much? R1 plus R2. Alright, and as I said, your homework. How? You have to do exactly the same way. Okay, the way you solve for this one, there's no difference at all. Okay, so this side becomes R2 minus R3. This side becomes R2 plus R3. Okay, this side was 6, and because of the rectangle, what do you get? This side is, this is a rectangle, so this side is 3. Can you see? The whole question, which was looking like a circles question, by just drawing two rectangles, we have converted it into a triangles question. Okay, so many times these kind of things would happen in the exam, that directly it may not appear like a triangles question, but you have to convert them into correct. Okay, AA similarity. These are parallel, so you can say this angle are same. Okay, very good. Okay, by AA similarity criteria, these two triangles are similar. Okay, so can we say that R1 minus R2 divided by R2 minus R3 is equal to R1 plus R2 by R2 plus R3. So by AA similarity criteria, these two triangles are similar, and we can say that R1 minus R2 divided by R2 minus R3 is equal to R1 plus R2 divided by. Okay, now let's just transpose these two. Okay, just take your time. Take your time. Yeah, is this clear? Okay, now we need to take the transpose. Because it is generally a bit easy to solve it if we have plus signs in the numerator, okay, and negative signs in the denominator. It's generally a bit easy. Okay, so what we do is we take this to the top, okay, and bring this to the bottom. Okay, so what do we get? R2 plus R3 divided by R2 minus R3 is equal to, we are taking just the transpose. Okay. R1. Okay. Is this clear? Now, have you heard of a property? Okay, this is a property. If A by B is equal to C by D, okay, then A plus B by A minus B is equal to C plus D by C. This is a property of ratio and proportion. If A by B is equal to C by D, then A plus B by A minus B is equal to C plus D by C minus D. This is called as componendo. Okay, you can note down. This is a property known as componendo dividend. Okay, A by B is equal to C by D, then A plus B by A minus B is equal to C plus D by C minus D. Got it? Yes. Let's apply this to this thing. Alright. So what we are going to do is, yes, any doubts in this? Please note down this property because it's comparatively an important property, okay, which you can use to solve very easily. You can use it to solve questions very easily. Try to apply it to this. Apply componendo dividendo to this one. So what do you get? The numerator becomes R2 plus R3. Okay, we are adding the denominator now. Plus R2 minus R3. Okay, we have added numerator and denominator in the numerator. This one. Okay. So we have done A plus B. Alright. Here A is the whole thing. This whole thing is A. This whole thing is B. Okay. This whole thing is C. This whole thing is yes. So R2 plus R3 plus R2 minus R3 divided by what will come? Very good. R2 plus R3 minus R2 minus R3. Very good. Okay. And on right hand side, what will we get? Similarly, okay, this will be R1 plus R2 plus R1 minus R2 okay, C plus D, divided by C minus D, which is R1 plus R2. Okay, minus here. So if we simplify, lots of cancellations will occur. R3 will get cancelled here. Okay. In this case, R2 and R2 will get cancelled. Okay. Here again R2 will get cancelled, and here R1 will get cancelled. Okay. So what will we be left with? 2R2 divided by 2R3. Check the signs, okay, guys, because minus into minus, this will become plus. Okay, take care. Will be equal to 2R1 divided by 2R2. Clear? So all the 2's would get cancelled again. So what will you get? R2 by R3 equal to R1 by R2. R2 by R3 equal to R1. Okay. Now you can cross multiply. Okay. What do you get after you cross multiply? R2 gets multiplied, so we get R2 square. R2 and R2 gets multiplied, we get R2 square. And these two get multiplied, we get R1 into R3. Okay, so we write it here. So R2 square is equal to R1 into R3. This is the first relationship that we have got between R and R3. Alright, till here, clear to all? Bit lengthy, but I think, yeah, you are following it. That's good. That's really good. Alright, so we got this. R2 square is equal to R1. Now, can we apply Pythagoras theorem to this triangle? Pythagoras theorem to that triangle. And tell me what you get. Apply Pythagoras theorem to the first triangle and tell me what you get. Between R1 and R2. Right. Yes. So this side is your hypotenuse. So R1 plus R2 whole square is equal to R1 minus R2 whole square, okay, plus 6 square. We are applying it to this triangle, only that triangle. So what do you get? Open the bracket. So R1 square plus 2R1R2 plus R2 square is equal to R1 square minus 2R1R2 R2 square plus 36. Will there be cancellations again? Will there be cancellations? R2 square gone, okay, R1 square gone. Okay. This can be shifted to the left hand side. So we'll get 2R1 R2. This will become plus when it comes to left hand side. Very good. Most of your 4R1 R2 is equal to 36. So what is R1 R2? This gives us R1 R2 is equal to 36 by 4, which is 9. Okay, 4 R1 R2 is equal to 36. Therefore, R1 R2 is equal to 9. So okay. Next one. Okay, next what do we do? Calculate for the smaller triangle. Okay, what will it be for the smaller triangle? Can you tell me? Similar kind of thing, similar Pythagoras theorem. Just for the smaller one. Okay, so same way, R2 plus R3 whole square is equal to R2 minus R3 whole square plus okay, so you'll get 4 R2 R3 is equal to 9. Okay, so R2 R3 will be equal to 9. That simplification, you do it. Huh? You have to again cancel it and bring all the terms to the left hand side. Okay, this clear? So this is our third relationship. Okay, R2 R3 equal to 9 by 4. This is the second relationship. Okay. Now just multiply the second equation and the third equation and third equation. What do you get? R1 okay, into R2 square. I'm just multiplying the left hand side, guys. Okay, R1 into R2 square into R3 is equal to 9 into 9 by 4. Correct? I just multiplied equation 2 and equation 3. LHS on one side, RHS on the other side. What is the advantage? What is the advantage? Yes, you can now substitute for R2 square. Correct. Okay, R2 square is what? R1, R3. So we substitute for R2 square. So what do we get? Okay, into what was R2 square? R1, R3. Okay, we are substituting for R2 square, yes. Okay, into R3 is equal to 9 into 9 by 4, that is 81. But there's an advantage here because of this. What is that? You can already start seeing that, right? So you get another relationship. Very good. Okay, so we get R1 square, okay, into R3 square is equal to 81 by 4. Okay, so what is R1, R3? To square root of 81 by 4, which is 9 by 2. This is our fourth equation. Okay, so what are the things we got? R1, R2 is 9. Okay, I'll just write these three, specific three to the, I'll take it to another place. R1, R3, R1, R2 is equal to 9. Okay, then R2, R3 is 9 by 4. R3 is 9 by 4. Okay, and R1, R3 is equal to 9. Okay, where is the area? Okay, so you may ask, we are writing down R1, R2, R1, R3, R2, R3. To our question. Okay, the question said area of this region. Okay, yes. Now area of this region, how will you calculate? Okay, essentially, how will you calculate area of this region? Yes, very good. Okay, so we can say that area of the orange region is equal to area of the big circle. Okay, area of the biggest circle, area of the biggest circle okay, minus area of right, area of all three circles. But that will also include region on this side. Correct? We don't want that. We want only on one side. So what do? We calculate this and divide this whole thing okay, by half, by 2. We take only half of it. So it's like saying area of the biggest circle minus the smaller circles will give you this side as well as this side. We take half of it because it's symmetric. Correct? So we take half of it and we remove this area. Okay, so area of the orange region is area of the big circle minus area of the three smaller circles together and take half of it. Okay, divided by 2. So let's write that down. Okay, now in terms of area of the smaller circles, so this is the big circle. This smaller circle inside it. There's another one. Okay, this another. Okay. Now, what is the diameter of the bigger circle? This diameter of each of the circles put together. Correct. So total diameter D is equal to D1 plus D2 plus D3. Correct. This is D1, D2, D3. Okay. With the same concept, can I say that radius, because I divide left hand side and right hand side by 2. Okay. This D1 by 2 plus D2 by 2 plus D3 by 2. Okay, what is that? That means radius of the bigger circle is is equal to R1 plus R2 plus R3. Simple? Yes. Now let's go for the area. Okay, area of the circle. Okay, so area of the, so our formula was half into area of the biggest circle. What is that? Pi into, okay, R square. This was the biggest circle. Okay, minus pi into, I'll put it in bracket, R1 square plus pi into R2. Okay, this all put together is sum of areas of the smaller circles. Alright, yeah, I'll close the bracket. Thank you. Clear? Yes. But what was this? We just now found that this capital letter R was R1 plus R2 plus R3. Okay, so what does this become? Half into pi into, this is R1 plus R2 plus R3 whole square, okay, minus pi R1 square minus, oh very good. So somebody is suggesting we can take pi common. Yes, yes, R2 square minus pi. Yes, correct. We can take pi common from all the terms. Very good. So we can write this as pi by 2. Okay. You remember the formula for a1, a plus b plus c whole square? We'll apply that here. What do we get? R1 square plus R2 square, okay, plus R3 square, okay, plus 2R1 R2, okay, plus 2R2 R3, correct, plus 2R3, okay, minus each of this would be there. Okay, so minus R1 square minus R2 square minus R3 square. Okay. Okay, they can be cancelled. So R1 square is gone. Okay. R2 square is also gone. R3 square is also gone. Alright. Again, we can take 2 common. We can take 2 common. So what do we get? So pi by 2 into 2 into inside bracket R1 R2 plus R2 R3 plus R3 R1. Clear? This 2 and 2 gets cancelled. Pi we can take as 22 by 7. Okay. So pi is 22 by 7 into. Now what was R1 R2? R1 R2 from our previous thing? Yes, we had. Yes. So R1 R2 is 9 plus. Next one was R2 R3. Okay. R2 R3 was how much? 9 by 4. Okay. Plus 9 by 4. And last one is R3 R1, which was 9 by 2. Okay. Yes. Okay. So what do we get? 22 by 7 into, take the LCM. Okay. So this is 36 plus 9. Okay. Yeah, if you want, you can take 9 common as well. Yeah, that can be done. Very good. Let's take 9 common. So 9. Okay, so this is 4 plus 1 plus 2. Okay, this is 7. Can you see 4 plus 1 plus 2 is 7. This is equal to 7. This part inside the bracket, 4 plus 1 plus 2 is 7. So we can cancel this. Gone. Okay. We can cancel a 2 here. 2. So our answer is 99, which is 49. Okay. Square units. That is our answer. So area of the shaded region, the orange region, is 49.5 square units. Patient, this was a quite lengthy question, right? Yeah, and thank you for focusing on it for so long. So we have a very nice thing for you because of that. Okay. You have an offer to join the session, to join the course on triangles, just the chapter triangles. Okay, at a discounted price. Okay, I'll just show you that page and give you the link for that page as well. So if you want to learn questions like this, okay, mostly the questions would have a tinge of this. We'll also solve the NCERT questions, but plus 1 or 2 questions like this. As you can see, it takes almost an hour to solve questions like this. Okay? But because this was the first time for you, I went very slow. But in this session, we'll be solving it a bit more quickly. All right. So this is essentially the offer page. You can see here. Okay, I'll be taking the class. And book your seat. Let me see what. Basically, we'll be having all the proofs and all the concepts related to the triangles one. We have the BPT, Thales theorem. All those things will be there. Okay, proof and application of Pythagoras theorem, areas of similar triangles, normal stuff whichever you have read, plus questions like these. Okay, and it starts on 3rd of August. Okay, coming Friday, I guess. Okay, and the timing is 7 to 8:30. 7 to 8:30. Okay, and you have a lightning deal. Okay, you can register at 499 rupees. Okay, it is for you guys only because you can see ends in a couple of hours. So if you want this particular discount, you have to register within that time. All right. So normal course fee is 1999. If you register tomorrow or later, it is somewhere around 2000 rupees. 1999. 499. All right. And I'll just give you the link, okay, for this course page. This is the link. Okay. HTTPS, that's for the secure connection. Vedanta is a secured site, so you don't have to worry about payments and other things because it's secured. Okay. S stands for secured, it is encrypted. Okay. VDNT, okay. VDNT. That's short form for Vedantu. .in India. Okay. Yeah, proud to be Indian. Vedanta is an Indian company, so it's a nice thing. So this is only for the chapter on triangles. It will be great to embark on a journey of knowledge sharing. All right. I'm G. Prasad, signing off.